Good morning, students. In previous classes, we have been discussed regarding speed and velocity and different types of speed and velocity. So in this class, we are going to discuss regarding acceleration. So acceleration, which we are going to discuss. This acceleration is defined here as the rate of change of velocity is called acceleration. So in simple format, if you have to remember, velocity you have been defined here as the rate of change of displacement is called velocity. We have been explained here. For acceleration, the rate of change of velocity is called acceleration. So this acceleration, which we can represent here as like this. So acceleration is equals to change in velocity by time taken, or we can write here as change in time also we can represent. So this in simple format we can write here as, so A vector is equals to, so change in velocity as we can represent here as v2 minus v1 by t2 minus t1. Because in previous class we have discussed velocity is a vector quantity which is having both magnitude and direction. So this in terms of magnitude we can represent here as modulus of a vector is equals to, so v2 minus v1, that's magnitude by t2 minus t1. So while using this equation in simple format, which we are using here as A is equals to v2 minus v1 by t2 minus t1. So this acceleration is a vector quantity. It is a vector quantity. That means it has both magnitude and direction. Whenever it is having both magnitude and direction, means we can tell acceleration can be positive, acceleration can be negative, or in some cases acceleration can be equals to 0. So SI unit is if you have remembered here change in velocity. For velocity you have been proved the SI unit is nothing but meter per second by second. If this second moves, so if you have been taken this meter per second by second, you can write here as meter per second square. So in simple form, you can write here as meter per second square, or m is to the power of minus 2. So in the same way, for CGS unit is, we can write here as centimeter per second square. That we can write here as centimeter per second square or centimeter is to the power of -2. Then dimension formula. So dimension formula in terms of MLD. So here mass is 0, length is power 1 and t power -2. This dimension formula which we can learn from the first chapter, units and dimensions. This is a simple form regarding acceleration. So the rate of change of velocity is called acceleration. We can write here acceleration as change in velocity by time, or we can write here as change in time also. So that acceleration A is equals to v2 minus v1 by t2 minus t1, because acceleration is a vector quantity. So it has both magnitude and direction. The units are meter per second square. CGS units are centimeter per second square. Dimension formula is m power 0, l power 1, t power -2. In previous class, what we have been discussed, different types of velocities. In the same way, here also we can tell different types of acceleration. So apart from that, now I'm going to explain. If you want this, please make it copy. Stop it and then you can make it copy. So in acceleration, we can tell here as instantaneous acceleration, instantaneous acceleration, so average acceleration, uniform acceleration, and non-uniform acceleration, These are the types which we are going to learn the same way what we have been studied in case of velocity. Here also we are going to discuss like this. So among this, now first as if I am going to discuss regarding instantaneous acceleration. So instantaneous acceleration already have been discussed. So acceleration of a particle. At a particular instant of time, which we can explain. So we can call it as instantaneous acceleration. So the help of definition we have been discussed. A is equals to v2 minus v1 by t2 minus t1. Here v1 and v2 are initial and final velocities, t1 and t2 are initial and final time. So this which we write here as acceleration A is equals to delta v by delta t. So at a particular instant of time, that means the delta t tends to 0. If delta t tends to 0, but it is not equals to 0. In such a case, instantaneous acceleration we can write here as limit delta t tends to 0, delta v by delta, that's acceleration a is equals to, we can write here as, which is nothing but dv by d. Here dv by dt is nothing but for small interval of time we can take. So with the help of this, I can write here as, so a is equals to dv by dt. So with the help of this, as if r being sent toward this side, I can write here as dv is equals to a into dt. So in terms of integration, if you have to find out for overall, that integration of dv is equals to integration of a into dt. So velocity will change, that v2 to v, that is v1 to v2, and time period is nothing but here t1 to t2. So these equations which we are going to use by solving the numericals. This is the integration form. So basics of integrations which we have been studying, or in mathematics have been studied regarding this integrating part. So based on this instantaneous acceleration which we can find. So a is equals to dv by dt. By using this equation we can write to find the change in velocity. So based on that we can explain. This is regarding instantaneous acceleration. So next one is uniform acceleration. Uniform acceleration. So in uniform acceleration, in the name itself they have been given uniform. It will be the same. So uniform acceleration. A body has equal change in velocity in equal intervals of time. In equal intervals of time. In equal intervals of time. However, the time interval may be small. The time interval is small. A body has equal change in velocity in equal intervals of time. Here, change in velocity you have been taken. Velocity is a vector quantity. That velocity can be changed, either it may be in positive or it may be in negative. So, with the help of this, whether velocity can increases or velocity can decreases. That in equal intervals of time. In such a case, we can tell here as the object is in uniform acceleration. So, with the help of this, which I can express here as I have been taken here. So this is the time in terms of second, and this is the acceleration in terms of meter per second square. I can tell here, for example, this is at 1 second, this is at 2 seconds, this is at 3 seconds, and here you can take some value which is nothing but 5 meter per second. So For example, we have been taken at 0 it is 5 meter per second square, at 1 second 5 meter per second square, at 2 seconds 5 meter per second, at 3 5 meter per second square. In this case, we have been taken from here to here, from here to here. Change in velocity, equal change in velocity in equal intervals of time. From here to here, how much it has been changed? The same it will be there, same it will be there in equal intervals of time. So, in such a case, we can tell here as uniform acceleration. So, next one is non-uniform acceleration. So, non-uniform acceleration. So, a body has unequal change in velocity, unequal change in velocity in equal intervals of time, equal intervals of time, in equal intervals of time. However, the time period may be small. Here, unequal change in velocity, or you can tell a body has equal change in velocity in unequal intervals of time. So, whatever may be, or third case you can take as unequal change in velocity in unequal intervals of time. In such a case, the body is said to be moving with non-uniform acceleration. So, this is the time in terms of seconds, this is the acceleration in terms of meter per second square. I have been taken as like this. So, here, this acceleration will not be a uniform. So, based on this, which we can tell. So, with the help of this, so last one is nothing but we can tell here as a jerk. Jerk, which we can define here as it is the rate of change of acceleration. Acceleration by time. How we have been defined here? Acceleration is equals to velocity by time. The same way, this jerk, which we can represent here as J is equals to acceleration by time. So, acceleration by time. So, in general, we are not going to discuss regarding this jerk. It is the rate of change of acceleration. The rate of change of acceleration is called jerk. And then final one is average velocity. This average velocity is nothing but the ratio of change in velocity by time taken between two intervals. The same phenomena which we have been explained for acceleration. So, with the help of this, we have been discussed all the parameters. So, what we have been discussed at the beginning: distance, displacement, speed, velocity, and acceleration. So, with the help of this, now we are going to write the kinematic equations. So, kinematic equations. So, kinematic equations of motion under uniform acceleration, under uniform acceleration. these kinematic equations which we are going to use in class 11 and class 12. So you should have to remember all this. I think so in class 9 also we have been studied regarding this kinematic equations. So apart from that, the first one is nothing but, so V is equals to U plus A T. The second one is nothing but S is equals to UT plus half A T square. And third one is, so V square minus U square is equals to 2AS. These are the three kinematic equations which we have been studied in class 9. The fourth one, Sn is equals to U plus A into N minus half. This is for nth displacement. Then last one which I will take here as, so average velocity, that's, sorry, average displacement, S is equals to V plus U by 2 into T. So these are the 5 equations which we can call as kinematic equations, but most of the cases we can tell 1, 2, 3. These are the basics. Here, this is the displacement for n second, and displacement, so whenever we have taken average velocity. So apart from this equation you have been seeing, we can tell here as velocity as a function of time. Why you have been called velocity as a function of time is, here acceleration will be same. So whenever velocity changes with respect to time, so that velocity as a function of time, as a function of time. So second one you have been taken, yes represents displacement. Displacement as a function of time. So displacement as a function of time. As a function of time. Then third equation, velocity, V represents final velocity, U represents initial velocity, A represents displacement. A is a constant, 2 is also a constant. So velocity as a function of displacement, as a function of displacement. So this is nth displacement. We can call it as nth displacement. And then this equation goes here for displacement. This formula I have written, S is equals to UT. So here this represents average velocity. Having 2 also, V1 plus V2 by 2. So that's indicated as a displacement. These are the kinematic equations. In this, V represents final velocity, U represents initial velocity, A represents acceleration, T represents time, and S represents displacement. And this Sn represents nth displacement. That is after n seconds. What is the displacement of an object? That which you can find by using this equation. With the help of this, now I'm going to prove so these kinematic equations 1, 2, 3 by using graphical method, as well as calculation method also we can be proved. kinematic equations. Kinematic equations. Using graphical method. Using graphical method. So this graphical method means already we have been discussed graphs between velocity and time and acceleration time, in this case time. Here I am going to take on x-axis, which I can take here as a time, that in terms of second, and then here velocity, which I am going to take in terms of meter per second. So let us assume that, so this is a body which is moving with uniform acceleration. Whenever it is moving with uniform acceleration means it will be having some initial velocity at a time period t is equals to 0. So from here to here I can take it as a, this is a, I can take here as a initial velocity as because velocity I have been taken on x-axis. It's moving with uniform acceleration. Whenever it is moving with uniform acceleration means like this, which I am going to get. Equal change in velocity in equal intervals of time. So let us assume that after some time, that means from here to here it will take some time. At this point, what is its final velocity means I can take here as a v. That point I am taking here as a v. So for my convenient purpose, I have been drawn a line, so like this. I have been taken this point as C and this point as B. Now, if you observe clearly, O to A is the velocity, initial velocity is U, and D to B is the velocity, final velocity, that means along x-axis, and O to D or A to C, both will be the same. The time period I can take here as a T. So this is the assumption which I have been taken. Now I am going to prove kinematic equations. So what is the first kinematic equation? The first kinematic equation is nothing but we have to prove V is equals to U plus A T. While discussing the concept, I have been said if it is making certain angle theta, that here slope is equals to y by x, which is nothing but tan theta is equals to y by x, or in simple form we can write here as which is nothing but velocity by time. So velocity by time, which is nothing but acceleration. So acceleration which I can take. So with the help of this acceleration, so acceleration is equals to opposite side by adjacent side. Here, what is the opposite side for this triangle ABC? So if this is a theta, this will be the opposite side. Here, opposite side is B to C, but O to A is initial velocity, that means D to C also will be the same. So if you have been subtract this will be nothing but B minus E. So B to C, that acceleration is equals to opposite side, I can make here as CB, by adjacent side, which I can take here as a AC. So this acceleration is nothing but A is equals to C to B is nothing but U minus V. That means B minus V by A to C. These are parallel and with the help of this, I can write here as V minus U is equals to A. Finally, I have proved V is equals to U plus A. So this is the first one, which we call it as a kinematic equation. So next, second one, Here, second one I have been taken. So second equation is S is equals to ut plus half at square. S represents displacement. So with this, you have been proved velocity v is equals to displacement by time. With the help of this, S is equals to what I can write vt. That means here displacement is equals to area of velocity time graph. Velocity time graph. So v is equals to s by t. With the help of this displacement, s is equals to, I can write here as v into t. So that means displacement is nothing but area of velocity time graph. This area O, A, B, D, O, this area we can call it as displacement. So with the help of this, I can write here as S is equals to area of O, A, B, and then D, O. I am not taking this part, now I am eliminating. So this I can take here as, by taking this, if you have been observed, ABC will be formed in the form of a triangle and OACD it will be in the form of a rectangle. So that which I can divide it as area of OACD plus area of which is nothing but ABC. So here, what is the formula for area of a rectangle? Length into breadth. Here I have been taken from here to here it will be u, from here to here it will be t. So with the help of this, A is equals to ut plus area of triangle. Area of triangle is half base into height. Half base. This is a base. This is a base. I can take it as a t. Into here base into height. Height is nothing but here they have given as v minus u. But what we require, we should have to do it as half AD square. From this equation, R, you can take from this. V minus u is equals to, we can write it as 80. With the help of this, S is equals to ut plus t into t, that is half AT into, t into AT, which is nothing but ut plus half AT square. So this is the second equation which we can do. So because I am having a little bit space only, that's why I am going to drop and then I am going to do the third one. Is it clear now? Okay. So third one which I am going to prove. Here, finally I can go here as S is equals to ut plus half AT square. So third one I am going to prove by taking this equation. So with the help of this, third one I am going to take as like this. Here also same, displacement is nothing but area of velocity time graph. That here S is equals to, now I am going to not consider regarding this in third case. So S is equals to area of OA B O. So this is a total B, this is initial U I can take. So this you have been observed clearly. The shape is somewhat like this. So anybody can say what is the shape? This is nothing but area of trapezium. So area of trapezium. So what's the formula for area of trapezium? Area of trapezium is nothing but S is equals to half into A plus B into H. Here, if you have been make this like this, if you have been turn this, here we are going to get it as like this. So this is a U value, and this is a V value, and this is a T value. So with the help of this, S is equals to half A is nothing but U plus V into height. Height is nothing but here. But what you should have to prove? Third equation. Third equation we should have to prove here as V square minus U square is equals to 2AS. But yes, we have been obtained here T. So again from this equation I have been taken, which you can prove here as V minus U is equals to A. With the help of this T is equals to write here as V minus U by A. By substituting that value, S is equals to half, that is you can write here as V plus U. So just as if I am interchanging, and then I am writing here as V minus U by A. With the help of this I have been taken 2AS is equals to V plus U by V minus U. So if you are good in mathematics, so A plus B into A minus B is nothing but A square minus B square. Instead of A, V value, instead of B, U value. So with the help of this, 2AS is equals to V square minus U square. These are the three kinematic equations which you have been proved by using graphical method. Students, please subscribe my channel and share to your friends. If you are having any doubts regarding the concept, please you can make it pin. So that means you can send message, or you can make it comment. So surely I will reply to you. So okay, students, thank you.